x is equals to 8. So there we have x is equals to 0 or x is equals to 8. Then it implies when, so solve the equation log 2x cubed minus log x is equals to log 16 plus log x. That is very simple. For you to solve any problem involving logarithms, now remove the logs. You see those logs. You can remember when you had a case like log xy, if you take the log inside when there is multiplication, it changes to addition. If you take the log inside where there is division, it changes to subtraction, isn't it? So it means when we took the log inside, we got subtraction, meaning there was division in that problem, isn't it? So when we remove the log outside, it means we go back to our original problem, which is 2x cubed over x. So that the moment we were taking the log inside, the division changed to subtraction. Are we together there? You are done with the left hand side, you go to the right hand side, you remove the log outside. Meaning if you remove the log, this addition goes back to what it was, isn't it? It was multiplication, meaning you add 16x. So that the moment you took the log inside, multiplication changed to addition. So it is a reverse process. You are going backward, isn't it? So you can see it is like you introduce log on both sides of the equation, isn't it? So you now remove the logs you introduce on both sides of the equation. It's a backward process, isn't it? So if you remove the logs you introduce on both sides of the equation, you don't cancel like that. You just ignore the logs. You just ignore the logs on both sides of the equation. Then you simplify. So here we have 2x cubed over x is, see x goes here, one you remain with 2x squared to be equals to 16x. So you can see one term is x squared, one term is x, meaning it is quadratic, isn't it? So when it is quadratic, you make it in form of a quadratic. You don't say x is common on both sides of the equation. No, when it is quadratic, isn't it? So you bring 16x this side. So what do we have? 2x squared minus is equals to 0. Say there. So what is the common term here? Factor. 2x squared minus 16x equals to 0. 2x is a common factor, isn't it? So if you remove 2x outside here, you remain with the first term here, you remain with x, isn't it? Then minus, if you remove 2x from 16x, you remain with 8, isn't it? So you factorize, isn't it? After factorizing, when two factors are equal to 0, it means it is either the first factor which is 0 or the second factor which is 0, isn't it? So this implies either 2x is 0 or x minus 8 is 0. So we have x is equals to 0 or x is equals to 8. So there we have x is equals to 0 or x is equals to 8. Then it implies when, are we together? Tuko pamoja? Yes. When x is equals to 0, then it means the problem is undefined. Are you seeing that? When x is 0, it means it is undefined because there's no log 0. Are we together? It means it is undefined. Then it therefore implies x is equals to 8. You must get all the solutions first. It's when you check whether all of them are applicable. Just like a case when you are maybe solving the length and width of maybe a square, the length and width of maybe a rectangle, and you are using a quadratic, method. Then you end up to get one of them to be positive and one of them to be negative, isn't it? Then you ignore the negative one saying the length is not negative, isn't it? Are you seeing such cases? You ignore a case which is undefined. Is that okay?